In this video, we are going to focus on solving problem about charges and Coulomb's law. So, everything is made of atoms. So the pen you are using in the computer you are using is made of atoms, and atoms is made of neutrons, protons, and electrons. Proton has no charge. Neutron has no charge. Proton has a positive charge, and electron has negative charge. And these three basic particles allows stuff to maintain their own charge, so they can either be positive, negative, or zero charge, right? So neutron has no charge. Proton has a positive charge. An electron has a negative charge. So when you are putting stuff with different charges, they can either be a repulsive force or attractive force. So we know for charges, the opposite charge attract each other, and the same charge, they repel each other. So opposite attract, same repel, right? So if you have a positive charge and negative charge, they're gonna attract each other. So positive charge, they will have a leftward force, and negative charge will have a leftward force. Positive charge will have a rightward force, and negative charge will have a leftward force. But if you have two negative charge, right, they're gonna repel each other. So this negative charge gonna have a leftward force, and this negative charge is gonna have a rightward force. Same thing, if you have two positive charge, there's also gonna be a repulsive force. So this one is also gonna point leftward, and this one is gonna point rightward. So opposite attract, same repel, right? Opposite charge, they attract each other because their charge is different, and stuff with the same charge, they repel each other, so there's gonna be a repulsive force. So how do we calculate the force? The force is calculated by Coulomb's law, right? Coulomb's law. So Coulomb's law is this equation here. Right, where F is the force, Q1 is charge of object 1, Q2 is charge of object 2, and R is the distance between two charges, or you can say two objects. And force has a SI unit of Newton, charges has a SI unit of Coulomb, and the distance has a SI unit of meters. So notice I put an absolute sign here because we know force is a vector, so direction matters. So if you point leftward, is usually represented by a negative sign, and point rightward is usually represented by a negative sign. However, in some case, you can get a result of a negative volume, but the force can be pointing to rightward direction. So it is always safer to calculate the magnitude first. So take the magnitude first, and then you can determine the direction of the force by see how different charges interact with each other. So now let's just do some basic physics problem. Positive 8 microcoulombs and QB is equal to negative 5 microcoulombs are separated by a distance r is equal to 10 centimeters. What is the magnitude of the electric force? The constant K is equal to 10 times 10 to the 9th power. So we know from Coulomb's law, the magnitude of electric force is equal to K times QA times QB over R, where R is the distance between the two charges. So now we just need to plug in all the number, but you need to convert their unit. So from microcoulomb to coulombs, you need to time 10 to the negative 6th power. So A microcoulomb is equal to A times 10 to the negative 6 coulombs, and negative 5 microcoulomb is equal to 5 times 10 to the negative 6 coulomb. 10 centimeters is equal to 0.1 meters. So convert centimeter to meter, you just divide it by 100. So because we want to take the absolute volume, so the negative sign here does not really matters, right? Because we are calculating the magnitude. And magnitude is always greater than 0. So 9 times 10 to the 9th power times charge A. So A times 10 to the negative 6 times charge B times 5 times 10 to the negative 6 over R square, so 0.1 square. And this should give us a result of 36 Newton, right? So 36 Newton is the magnitude of the electric force. So you can also determine whether the force is attractive or repulsive. So because QA is a positive charge, so positive charge for QA and negative charge for QB, so there's gonna be an attractive force. Or it can be something like this, I don't know. So you know there's a attractive force between the two charges. So now let's take a look at problem B. Their charge, mass, and radius are also given. If both balls are free to move, which ball will experience a greater force? Explain. So from Newton's third law, we know when objects are in contact with each other, they experience a force that is equal in magnitude but opposite in direction. So for those two charges, they also experience the same amount of force in magnitude, but their direction are opposite. You can also see this from Coulomb's law. So we know force is calculated by K Q1, Q2 are over R squared, where R is the distance between the two charges, and Q1 and Q2 are the charges of object 1 and object 2. So from this equation, you can see that both charges experience the same magnitude of force. So same amount of force, same force. For B, when the ball collects, which will be moving faster? Explain. So for part B, you can use conservation of momentum. Right. So initially, two balls are at rest. So initial momentum of the system must be equal to the final momentum. So initial momentum is equal to 0. So when they collide with each other, they must have the same magnitude of momentum but opposite in direction, so the total momentum cancels out. So this system has a final momentum of 0. Right? So let me write this is equal to Pi plus P1F plus P2F, right? And this is equal to 0. So what we can know is the magnitude of P1I is equal to the magnitude of P2F. So which one will move faster? So we know momentum is equal to mass times velocity, right? And because charge 1 has a mass of 10 gram, and mass 2 has a mass of 40 grams. So M2 is greater than M1, right? So V2 is equal to P. Let's say P1F is equal to P2F is equal to P. So V2 is equal to P over M2, which is going to be less than P over M1 because M1 is less than P2. So charge 2 is going to be moving at a faster velocity. So Q2 is faster. Right. C. Find the force and magnitude on each ball. So this problem is very straightforward. You can just apply Coulomb's law to find the force on each charge. So the magnitude of force on both charges are equivalent. So F is equal to Coulomb constant, so 8.99 times 10 to the 9th power times charge 1, 6 times 10 to the negative 6 times charge 2, negative 2 times 10 to the negative 6th power over their radius square. R square is equal to 20 times 10 to the negative 2, and then square. So this gives us a result of 2.697 Newton. Let me check my calculation. This is correct. Negative 2.697 Newton. But what we want is a magnitude of this force. So I'm gonna put an absolute. I'm gonna take the absolute volume here. So this is equal to 2.697 Newton. Right. So now you just need to find the direction on each ball. So both balls, charge 1 has a positive charge and charge 2 has a negative charge. And we know opposite attract each other. So the negative charge is gonna try to pull the positive charge a little bit closer. So there's gonna be a reservoir force for charge 1. And same thing for the negative charge. The positive charge is gonna try to pull the negative charge a little bit closer. So there's gonna be a reservoir force. So for F1, the magnitude is 2.697 Newton and the direction is rightward. And for F2, the magnitude of the force is also 2.697 Newton, but the direction is leftward. So this is the answer for part C. The last part asks us to find the magnitude and direction of the acceleration on each ball. So acceleration is equal to force over area. And because we want to calculate the magnitude, I'm going to take the absolute volume here. So for charge 1 is going to be equal to F over M1, which is equal to 2.697 over 10 grams. So you need to convert that to kilogram. So 10 divided by 1,000, which is equal to 0.01. And this gives us a result of 269.7 meter per second. So this is the acceleration of charge 1, and the direction is rightward, since the force points to the right. And for charge 2 is gonna be equal to F over M2. Let me erase this. Which is equal to 2.697 over 40 grams. I need to convert that to kilogram as well. So 40 divided by 1,000, which is equal to 0.04. And this gives us a result of 67.4 to 5 meter per second. And the acceleration is pointing to the left, since the net force is pointing to the left. So this is the answer for part D. Now let's take a look at problem 3. Two charges QA, QB is equal to positive Q are held fixed on the y-axis at 0, 3D and 0, negative 3D. A third charge, QC, is also equal to positive Q, is released from rest on the x-axis at 4D, 0. Which way will QC move? Explain. So for those type of question, it is important to draw a picture first. So here is QA, here is QB, and here is QC. And here is 3D because this QA is whole on the y-axis at 0, 3D, and here is also 3D. And for QC, here is 4D. So which way will QC move? We know QA is a positive charge, QB is also a positive charge, QC is also a positive charge, and we also know the rules. So like, repel, opposite, attract. Because both QA and QC are positive charge, so there's gonna be a repulsive force between them. So QA is gonna try to push QC away. So the force is gonna be something look like this. This is FA. And same thing with QB. It's also a positive charge, so it's gonna be a repulsive force between QB and QC. So QB is gonna try to push QC away. So we know because here is 3D, here is 4D, and here is also 3D, here is also 4D. So what we can say is the following: RA is equal to RB is equal to R, right? And we also know QA is equal to QB is equal to Q. So FA, the magnitude of FA must be equal to the magnitude of FB is equal to F. So FA is equal to FB in magnitude, and now just need to find which way they move. So to find the direction charge C moves, you need to find the net force QA and QB produce. Right. So here, let me redraw this picture. So here is FB, here is FA, and they're equal in magnitude. So you can separate them into different components. So a horizontal component for FB, a vertical component for FB, a horizontal component for FA, a vertical component for FA. Then what happens is a vertical component cancels off, so it looks something like this. And this becomes a net force. Right. So this is fax plus fbx. So let me erase this. Alright, so this is gonna be equal to 2fax. It's also equal to 2fbx because fa is equal to fb in magnitude. So now the net force point to the right direction, though the charge will also move in the rightward direction. So right. So describe the motion of charge C. Does it speed up, slows down, turn it around? Where is it fastest? So we know the net force point to the right direction, and we know the final velocity is equal to initial velocity plus acceleration times time. So since if the net force point to the right direction, which is a positive direction, as time increases, acceleration times t is gonna increase. So final velocity gonna increase. So charge C is gonna speed up and move in a straight line. So it's gonna move to the right direction. So problem C asks, find the force, the magnitude, and the direction. So how do we do this? What they're asking you is find the net force. So F net is equal to 2 fax. Is also equal to 2 fbx. So we just need to find the magnitude of this quantity because we know the net force point to the right direction. Right. So let me erase something. So how do we find the net force? Well, so let me do this. This is F net. So F net is equal to 2 fax. Is also equal to 2 fbx. Right, and here from geometry we know this is. From geometry we know this is fa. And here, vertical component, horizontal component. Here is 3D, here is 4D. So here must be 5D, which is equal to RA. And let's say here is theta. Then cosine theta is equal to 4D over 5D is equal to 4 over 5. And fax is equal to f cosine theta. So it's going to be equal to fa times 4 over 5. Right? So now you can plug this equation into here, and then you can find the net force. So let's do it. So this is going to be equal to, so here this equation is equal to fax. So this is going to be equal to 2 times 4 over 5 times fa. So a over 5 fa. So how do we calculate fa? So fa is equal to k qa qc over ra square. Right? And we know ra is equal to 5d. So RA square is equal to 25D square. And we also know QA is equal to QB is equal to Q, and QC is also equal to Q. So this is going to become A over 5 times KQ square over FD square, which is equal to 125 on the bottom, 5A on the top, times KQ square over D square. So this is the magnitude and point to the right direction. So this is the answer for part C. So now the question asks us to repeat A to C if charge C is equal to negative 2Q. So let me draw the picture again. Here is QA. So I'm just gonna write Q here. And here is also Q. Here's QC. And QC is equal to negative 2Q. And we know here has a distance of 3D. Here has a distance of 4D. And actually, I'm still write QA, QB. And because QA is positive, QB is positive, then there's gonna be attractive force between QA, QC, and QB, QC. So our QA is gonna try to pull QC closer to itself. So it's gonna generate a force like this, where the arrow of the force point to QA. I think same thing with QB. QB tries to pull QC closer to itself. Then the net force is gonna point to the right direction here. So here, F net. So let me redraw this picture here. So you know this force is FA, and this force is FB. And then you can separate them into different components: horizontal component, vertical component. And the vertical component cancels off. Then it turns something like this. Where the net force is equal to 2FAX is equal to 2 FBX. Right? Because FA and FB are equal in magnitude. So now I just need to use trigonometry to solve this problem. So we know the force FA. Let's say here is theta. And we know here is 4D, here is 3D. Then FAX is equal to F cosine theta, which is equal to F times 4D over 5D because of trigonometry. So FAX is going to be equal to FA times 4 over 5, right? And then you can plug this equation into this equation to find the net force. So F net, let me change the color. F net is equal to 2 FAX is equal to 2 times 4 over 5 FA is equal to A over 5 FA. Then how do we calculate FA? So FA is equal to K QA QC over RA square. So you know here is 3D, here is 4D, so here must be 5D, and this is equal to RA. So QA is equal to Q, and QC is equal to negative 2Q. RA is equal to 5D, so RA square is equal to 5D square. So this is equal to KQ square over 25D square, and here is a plus negative 2. So I'm gonna ignore the negative sign because I want to find the magnitude here. Then FAX, so you can plug this equation in. FAX is gonna be equal to 2KQ square over 25D square times A over 5. So this is equal to 16 over 5 times, it's 16 over 125 times KQ square over D square. And this is equal to the net force. So let me make this a little bit smaller here. and this is the answer. This is a net force. So this is the magnitude, and it point to the leftward direction. Right. So how do you describe the motion of QC if QC is equal to negative 2Q? So since the net force point to the left direction, it's gonna move to the left direction, right? And QC is gonna oscillate between 4D and negative 4D, and you move fastest when x is equal to 0. And this is the answer for part B. So now we have finished the problem if charge C is equal to negative 2Q.